Okay, so in our last video we set up this sample where we had an animal class and then we created a lion that extends from animals, so our lion is a child of animal. So in this video what I want to get across to you is what happens when we instantiate a child object. Okay, I'm going to get rid of this animal one for the moment. Alright, so we're creating a new object, we're creating a lion object, and the lion is inheriting from animal. So what I want to do to demonstrate my point here is I'm going to create a no argument constructor. So public animal, and it's a no argument constructor. And what I'm going to do is, I think I have this, yep. What I want to do is when this constructor runs, we're going to print out animal has been created. And let's do the same thing with, so that we can see that again. Let's do the same thing with our lion. So we're going to create a no arg constructor for lion. No arguments are going to be involved, so this is the default if I don't send any arguments. And then we're going to system.out.print. Why can't it just say print? Wouldn't that be so much easier? Print line. Lion has been created. Okay, so what we're going to do now is see how this works. Let's go ahead and run this and see what our output is. So this tells us that you can see both of those print lines were created. Both of those print lines ran. And what happens when you create an object of a child, first the parent constructors run, and then the children constructors run. So in other words, and I'm going to use some different code here, I'm going to type out, let's see, sorry about that, I'm trying to copy some code someplace else so I don't have to keep typing that up. I'm just being lazy. Okay, so what I'm going to do, and this is not working out the way I hope. Okay, so I'm going to print out this keyword instance of gives us a Boolean, true or false. Is the lion an instance of lion? Is it just a true or false? It's a Boolean. And then is the lion an instance of animal? So which is it? Is it an instance of a lion or is it instance of an animal? Let's see. In fact, it's an instance of both. So an instance of both of those objects are created at the time that you create your child instance. And why do you care about this? Well, I'll show you why. Okay, let's suppose, I don't need these anymore. Let's suppose that in our animal constructor, it was set up so that we have to have a name, string name. And we have to set the name at the time, so I have to put private string name. And at the time of instantiating an animal, I must have a name. So I no longer can create an animal without any arguments. I have to at least have the animal's name. So this dot name equals name. All right. Well, does that create any issues? I don't know. Let's see. So if I created a new animal, the animal equals new animal. Well, now we all know that I have to send it a name. So we'll call it Fred the lion. That's where we're going with that, I guess. I don't know. Okay. So now when I run animal, I have to have a string name and everything should be working out just fine. Well, let's run it. I got a compile error. Why? Well, because when we suggested originally that in this video that when I create an instance of the lion, it's creating first an instance of animal, and animal requires a string name. I'm not providing a string name. That's a problem. Okay, so we can verify that that works. Fred seems to be working, I would assume. Oh, animal has been created. Okay, so that's good. Must not have saved it because that shouldn't be generating me an error. Let's run that again just to verify. Why are we getting an error message? Let's see. Oh, because of the same issue I've been talking about. Okay, so here's what's happening. Here's where my little red dot is. It's in lion. So what we need to do is, lion is upset because it says I'm a child of animal, but I'm not sending animal the appropriate parameter, the appropriate argument when I'm creating an instance. So here's what we need to do. We need to come into lion, and we're going to use this keyword super again. So we're going to send a name, which we have to receive in lion somehow. So we're going to receive a string name. Okay. And so now when we run lion, super, this has to be the very first line in the constructor. So when we run the constructor now, we can say, when you run the constructor for the parent, which is super, when you run this constructor, and you can have more than one constructor. What if we had a constructor that was overloaded, that was receiving several arguments? The point is that by using super, that's how we can send the appropriate arguments to the appropriate constructor in the parents class. So now, when I run lion, the very first line that has to run is the line that's sending the argument to the parent, because the parent's going to be initiated first. So now I'm going to have to send, what's the name for another lion? Fido, I don't know. Okay, so now we shouldn't have any compile errors, because when we run animal, it's sending the string. And so what we could even do, instead of animal, why don't we do this? Name plus, there we go. That way we know who's being created. Okay, so now let's run it and see what happens. Fred has been created because that's the constructor for this object creation. Okay, and then we ran this object. We created a new lion object. Its first task, let's see if I can put these side by side. Its first task was to, when it created an object of itself, of a lion, it's going to first run the constructor of animal because it's a child of animal. So super says use the constructor for my parent and send it this particular argument, which this was required as our constructor for animal. So this ran. Now animal has a name, now lion has a name, and his name is whatever we left, Fido, so that printed out, and then this line printed out. So it's really important to understand the order of these things and to pay attention to, if my parent is being called first, does it require an argument to be sent to it? Maybe we also wanted to do animal, and we have let's do an override constructor, maybe age. Oops, that doesn't need to be cat. And so now we can say this.age and then equals age. And so now we could still set this up with, perhaps we have an overload here. Public lion string name, spelling is important, int age, and maybe here we're going to, what's my error now? No suitable constructor found for animal. So we need to make sure that we super name age. So we call our, let's see. Oh, we didn't do a name here. That's why it's upset. Okay, so we'll just do age. Here we go. Super age. Now we've got rid of all of our red squiggly lines. And we will set the age, and maybe we need to still print out Rio has been created. Okay, let's get rid of this so you can see all of that at once. See what we've got going on here. And so now when we have some overloaded constructors, which are legal because they have different argument types, or parameter types, excuse me. So now when we are going to run our super, it's going to run the one that has the age. So this one's going to run, nothing's going to print out here. And then let's say we do name has been created. Actually, his name hasn't been created yet if we do this. Let's see, we'll do lion has been created, and maybe lion is, we'll put his age. That makes no sense, but you get the idea. Okay, lion has been created, and then his age. Okay, age, there we go. That makes sense. Okay, so now we might need to create, when we create our lion object, maybe we'll create a second lion object. Lion, the lion 2, new lion, and we need to give him an age. He's 5. Okay, so we're creating 2 different objects using different arguments, using overloaded constructors depending on which one we're running. And those overloaded constructors are going to run the appropriate parent constructor and send the values that are needed. Whew, that's a lot. Okay, so does it work? There you go. Okay, so the key here to pick up is the fact that when we create an object, the first thing that's run is the parent's constructor, and we have to follow all the rules of constructors we've done before. And then the constructor for the child runs. If the parent requires a argument to be sent, we need to make sure we send it. We use that with the word super, and then we send whatever arguments are required. And super has to be the very first line in this constructor.